Hi, today we're going to be discussing updates in Microsoft Direct Routing. My name is Brian Ricks, and I work with Brightcomp IT Consulting Services out of Arizona in the United States. I am a Microsoft Teams MVP, and let's get started. All right, the agenda for today is direct routing as an overview, what it is, high level, what it is and isn't, updates on partnerships to direct routing, what's new and what not, new deployments that have occurred in Oceania, Australia, what it is, why it is, and what that means to us, and two new features, local media optimization and branch office survivability, better known as the SBA. Enterprise voice that is in the cloud is made up of three components. There's the Teams license itself. Without it, you can't get into Teams, can't do much of anything. There's the phone system license, which is very much equated to a PBX, a physical phone. It's the device that's managing the actual call itself. So without it, we can't make calls, we can't do any of the complex communications, things of that nature. And then there's the PSTN dial tone. The dial tone is either provided by Microsoft calling plans, right? A turnkey solution provided through the internet specifically to allow a user to get a phone number, use the phone number, be billed in one place, turnkey, all one solution. Works great if that is what you're looking for, no additional infrastructure, right? That's the calling plan. It is only available in some regions and locations, so it doesn't work for everyone, even if they want it to. And then there's direct routing. Direct routing can be utilized by whomever, wherever. It's basically bring your own trunk, right? It's bring your own communications to Microsoft Teams. The direct routing is the concept that when you're in a call, that call is coming over your architecture, over your session border controller, over your PSTN service, whatever and however that may be. And together, that gives you the entire enterprise solution, stacking all three of those together, whether it be plans or routing, along with phone system and Teams, into boom, the enterprise voice for the cloud. The benefit of using the various solutions really is dependent upon the users because there's different reasons, right? Some people want the turnkey solution, some people want the direct routing, but in this case, we're definitely going to go into the direct routing side of things. So conceptually, it is as simple as a PSTN provider on one side, your certified, extremely important, certified session border controller in the middle, and Microsoft Teams with the cloud PBX, aka phone system, aka the PBX on the internet side. So it could very well be that you have an internet-based SIP trunk coming to your on-premises um, session border controller or SBC, and it sends it right back out to the internet to Microsoft. That's highly plausible. It could also be that your SBC has a media gateway functionality within it. So you have a PRI or a BRI, or maybe you have FXO and POTS lines or some other communication that's coming, whether it's ISDN or any, it really doesn't matter, right? As long as there is a PBX type solution that you're doing PSTN communications directly into the session border controller and it's certified, it can then send that communication via SIP over to the phone system for Microsoft. So the certification is highly important, and I keep going back to it because it allows Microsoft to work with the various vendors, whoever it is that happens to be certified, to ensure that everything works end to end. And if Microsoft makes a change to their service, it continues to work with the certified SBCs. And if it does not, for whatever reason, Microsoft will work in a timely manner to fix it. They regulate and manage who and what can connect to their service. So you got to kind of use a certified session border controller. Highly important. So why would I want a direct routing solution versus the phone solution? Well, again, it could very well be that there is no calling plan in your region. If there's not, you have no choice but if you want to use enterprise voice to use direct routing. It could also be you have a, a contract with a local SIP provider that is highly advantageous to you and your company, and you have no desire to break that contract or move along. Maybe it's you have additional PBX infrastructure or third-party tie-ins to other systems or telephony requirements that are beyond basic SIP that you need to have on premise. You can have all of that and you can integrate all that with direct routing and Microsoft, all kind of glued together with the SBC. The session border controller brings all that together. Analog's a great example of sometimes you need to maintain a fax machine or a credit card machine or some sort of communications that's tied into your current infrastructure, but you want to get it all digital. You want to get it all over SIP. The SBC can help you to do that, but you'll need that on premise and not within the cloud in order to make this work, right? So that's why we would go with the direct routing methodology. Okay, so again, very high level, that's what we got. Updates on partnerships and what exists. So as you may or may not know, AudioCodes and Ribbon we're the first getting things going with the direct routing communications. And then we kind of go in order as we go down the list, then Oracle and AnyNode, and then finally Cisco jumped on board to be part of their SBCs, would be certified, at least for partial, if not all functionality to work with Microsoft Teams. Just recently, Nokia, Avaya, and Ericsson were added to the partnership team. Yay, great for us. And new and more companies and more compatibility. The Nokia and Ericsson are extremely important because they provide carrier SBCs internationally. So that opens up all kinds of doors for allowing direct ISP communications with the telcos remotely that will allow them directly to integrate with Teams and provide a better turnkey solution for clients and end users. Metaswitch, which I kind of left out on the right side, that's there too. That was recently acquired by Microsoft in 2020, so it doesn't really count in my opinion, haha. But in reality, it does. It's another solution, and it just adds to the great portfolio that exists. You'll also notice "and others stay tuned" is listed. Nothing much more can be said other than there are a bunch of medium to large SBCs that are under certification, whether they be virtual SBCs or physical SBCs, 10 plus in the mix of certification that will allow an even greater umbrella of SBCs to be in the environment that are certified. And that's highly important from a Teams perspective because that means we have the potential to have a lower entry point cost to get voice into Teams. If we already have the infrastructure on premises, because we already have those session border controllers, then there's a potential, if it's all compatible and versioning and everything works out, that we could utilize existing hardware to get us into the cloud. So that's great. So that's new information coming, and with more coming, right? Watch the internet, watch for updates, that's all good. Oceania and Australia. Now, COVID-19 drove a massive requirement for new infrastructure in Australia and Oceania. Basics are there was a massive spike of communication during COVID that put a massive load on Singapore, which was the direct hop outbound previously. So 2 new infrastructure hubs were added in Australia, 52.114.20.29 and 52.114.16.74 that have already been added to the SIPAL DNS record. So communications are already valid and could very well be being sent and received from those locations for those users that travel and move around. The actual utilization is now available to anyone that wants to use them, and it makes sense to use their routing from there, and it's highly encouraged to do so. It obviously reduces latency, better call quality, everything works out better for everybody. So that's new, and that's an applause that was, I guess, sadly driven by COVID-19, that the pandemic actually created something great in that forced a development of new infrastructure into Oceania and Australia. Okay. So with that, we're going to get into the 2 new features, the first one being local media optimization, the second being the SBA. Now, local media optimization, media path optimization, media bypass, direct routing, or media bypass for direct routing, or double media bypass, however you want to call it. This feature came out in early 2020. So what is it, how it works, what's the logic? Let's get into that. Local media optimization is defined as the ability to optimize the media that is being sent from the Teams client to Microsoft and where we want that flowing to go. So ideally, we want to centrally locate an SBC in the centralized SBC design and keep all of that media on WAN, on our local network, or even the LAN, right? We want to make sure that we are not traversing the internet with our media for security, for optimization reasons. There's all kinds of reasons we may want to do. But basically, from an improved security, media remains on the WAN. It talks to the internal SBC IP, not the external. And so it never has to go through firewalls, or shouldn't, depending on your network and how you're configured. And that, therefore, we can optimize the network and the optimization specifically to LAN traffic. So the SD-WAN MPLS clients can configure this with their ISPs. If in fact the ISP is managing their SBCs, that's an option. It can be internal to your own network that's in an SBC that you own. It really is flexible from a centralized concept of where this SBC, one or more, are living. But the basic idea is we have two user types, an internal user and an external user. Now you may be saying, well, how do we know if it's an inside user or an outside user? And that's defined wholly and simplistically by your subnet that you're on, along with your trusted IP. Now, a trusted IP is an IP that is your internet-facing IP address. So in many instances, it's NATed, but if you were to open up in Bing, what is my IP? It would come back with what the internet sees you as when you're traversing the internet, right? So when Teams is going on the internet, who is it? Who am I? What IP am I utilizing? Those IP addresses are defined as trusted IPs in the Microsoft Teams Admin Center. And those, along with the defined in the same place, your subnets that are within your organization, those two are married together. And that creates this awesome solution that says, hey, you're inside the network because I know this is you. If you think about it, if we had a 192.168.6.0 address on the inside, and at home I happened to think I was, awesome, and put that same IP address on my home network, well, without that trusted IP, I would look like I was inside the network, and that's not what we want. So those two together, which you can only get the public IP address if you own the public IP address, and that's going to be on the inside network, plus your subnet that you're defined on as a client, those two together get you to the list. And if you think about this even more so, really the trusted IP can be any trusted IP that's on your list, and then the subnet is more defined. It's taking you to a region you defined within the admin center, to an actual location in the admin center, and then based off that, we can do voice routing policies and more information, right? So inside the network, when we're looking at this, the user is communicating to the phone system. That's your blue line. So HTTP communication goes constantly over the Teams network directly to and from Microsoft. That's kind of like the management piece. We have to have the controlling of the call and management of the call happening from the Teams client to Microsoft. Otherwise, we won't know what's going on. The media flows from the user to the centralized SBC, and then it's a back-to-back agent. So the SBC then takes that communication and sends it over to the PSTN network. That PSTN network has the ability to be however it's connected. It could be a SIP trunk, it could be a PRI, BRI, ISDN, POTS line. Again, it doesn't matter. It's irrelevant to the Teams user as long as there is a calling path to go outbound to the PSTN network. The SIP communication still is maintained, and in this case from Amsterdam to the phone system, because Amsterdam has the direct routing configuration and the public IP of itself set up and communicated and all pre-configured in the direct routing communication. So all media stays on network, nothing goes outside, and it's optimized for the internal user. The external user has a similar experience. It's just they're talking to the public IP address instead of the internal IP address of the Amsterdam SBC, because they're defined to talk to Amsterdam, that's fine. But since they're outside the network, they're not going to be able to hit the IP address or the internal IP address of the Amsterdam SBC. So instead, it talks to the public IP address, the Teams client, and then everything else remains the same from a flow perspective. So that is what is known as centralized local media optimization. We also have the ability to do proxy SBC, local media optimization. Now, with the proxy SBC, there's a multiple ways to set this up. There are all kinds of configurations and ways for this to happen. The proxy SBC is the concept of I have multiple SBCs, one or more are publicly connected, have a public IP and talk to Microsoft. The others do not. Now, the main proxy SBC that's talking to Microsoft may or may not talk to the PSTN network. In this design, it does not. In this diagram, the PSTN network is simply talking to the sub proxy SBCs, and then they talk to the home network that talks back to Microsoft. So this is highly important when we have regulated environments. There's no way around this, but when you're in an environment such as India, such as China, that doesn't allow the communications to traverse the PSTN, the egress, anything but from a local network, right? No toll bypass, then we need to ensure that when you make a call, regardless of how that communication is configured, that the PSTN egress is local. So in this scenario, we have Vietnam that is configured and talking to the PSTN network. And then we have France underneath it that has an SBC as well. And that communication is what allows the communication to flow directly out its local user. So user A. So we have the user in, let's back it up. We have a user that's in Vietnam. That Vietnam user is configured to use via voice routing policies, the Vietnamese SBC, and the communication to Microsoft, however, is done directly through the Amsterdam SBC, right? So the Amsterdam SBC has the communication to Microsoft. So from a networking perspective, from a SIP communication perspective, direct routing is configured between it and Microsoft. The communication between Vietnam and between Vietnam and between Singapore, is done via a SIP trunk between those two SBCs. So it passes it over, and then the communication from Vietnam leaves via the PSTN network. So I hope that all makes sense, right? So I'm a user in Vietnam. I make a call. My call talks to Teams because, again, we have to have that HTTP communication that's happening between teams all the time. So it talks to Teams. Teams says, hey, I want to make a call. It says you're authorized to make a call via the Vietnam SBC. It then makes the call request to hit the SBC. The communication media flows outbound from that SBC, but the SIP communication that's being managed by the phone system network for direct routing is happening via the Singapore SBC. So all transparent to the user, obviously, but that's physically how we can kind of stack SBCs behind other SBCs to make the communication happen in our network. Now, that's a user that's on the home network and makes things happen. But what if they're external, right? Because we have the same communication potential problems or convolution when we're outside the network versus inside. So we use the same trusted IPs. We use the same subnet IPs to identify where you're at. But then if you are forced to be going outbound your Vietnamese SBC, if you're on the outside, that communication hits its first hop because that's where your media is going to flow to as a user, because again, that's what's exposed to the outside network. So user to the Singapore SBC, but then that communication will then leave Singapore and go to Vietnam. The Vietnamese SBC will then send it out, media out the PSTN network, therefore not bypassing any laws or media digression. And I should say, it doesn't have to just be for laws and reasons why you do this. There's all kinds of communication flows that you may want to handle this way. You're optimizing the flow based off proxies because of all kinds of regulatory information and or just best pathing for you. Maybe you can make some better communication going from site A to site B versus B to C. And that's really what the always bypass versus only for local user bypass concept is. When we're legally trying to bypass people, we set them to always bypass so that user in any office, in any country, media will always flow through the associated media bypass solution. So in this scenario, the user is, let's see, from Germany, but they're visiting France. So their voice policy says, hey, this user is supposed to use the Germany SBC. So that user in France, when they make a call, they then send their media back up to Germany, and then Germany sends it out and does the whole media optimization path. But the communication and the media optimization happens because it's an always bypass. We're always gonna go and send it to the site that they're designed to be in, right? So user in any office in any country, media goes to the SBC that's assigned to the user. Then there's only for local. That's another option that we have for configuration. So the user we see is not in the home site, but is in the internal network. So this can be configured this way if you have bad communication. So let's say there was a poor communications between the Vietnamese and the Indonesia locations. It just was poor, the network, or maybe there is no WAN communication. Maybe there's no direct hop that goes between the two sites, and so it's just high latency. It's not optimal communication. In this scenario, we would want to have the user routing to his best SBC next communication point from a media perspective to get the most optimized media flow path. So bad communications, no communications, WAN outage, problems with the physical routes. If a user's connecting from the remote office, they're treated as internal, but they're not treated as local, right? So media flows from Indonesia to Singapore and then passes off to Vietnam because of the proxy laws that we had before. As we're saying, this user has to route out this particular information. But local users only allows us to design a solution based off the physical network limitations that are in our environment, based off what we know and or what we have available to ourselves. Okay, so that's all the media optimization. Basically, we can make it happen the best way possible, get media to flow, which is the most important thing, right? SIP communication from the client, whether it be the signaling that's going for the HTTP REST back to Teams, or the SIP communication itself that's coming from the SBCs to the providers is low impact, low latency, doesn't have issues. It's tiny, but media is highly important, right? We need media to get there as clean, as fast, and as efficient as possible. So that's what the media optimization is for, to make it the most efficient route. Now, the survivable branch appliance is the idea that we have a office that is remote, typically. Although it doesn't have to be, it can be the main office. It's really designed to say, if in the event something happens catastrophic, something goes down, we need to go ahead and address it. We need to make the calls still come inbound and outbound. So what is the survivable branch appliance? The SBA is a registrar or a device that allows the Teams client to talk to the SBA, to this device, register or log in, and then when it's logged in and registered with this device, make calls in the event that Microsoft goes down. So your Teams client may not work for most anything, but it will be able to send and receive a call. There's a lot of reasons that this scenario may happen. It could be that you have a PRI, and so you have communications up, but the internet's gone down at your office. If that's the case, then your calls would still be able to come in and outbound to your Teams clients, desktop clients, because it works still, right? In this first version, calls can come in, calls can come out. Everything works as would expected from a call perspective. More importantly, calls aren't even interrupted or dropped if you're using an SBA. So we'll get a little bit more into that, but it allows things to make calls in the event there is no internet, assuming that you're not doing your voice over IP, your SIP trunk over internet. Then both would be down. That wouldn't work. But let's say you have issues with a branch and getting that office over the MPLS network, or maybe it's a site-to-site VPN and that's down for whatever reason. Well, just because you can't get back to the main office doesn't mean that your phone system should go down, and it can be completely separated and independent. Or maybe, heaven forbid, there's a Microsoft outage. Microsoft goes down in Teams, and for whatever reason, you can't log into the Microsoft Teams world, it doesn't matter. You'd still be able to make a call with a couple of different caveats. So that's what the SBA is for. It's to provide a solution in some key scenarios where there's an outage to the Teams infrastructure in one method or another, and phone calls can still be made inbound and outbound. Okay. So there are 4 vendors that are currently working with Microsoft to create this SBA solution. The solution is a designed solution by Microsoft, but an implemented solution by the vendors. That makes sense. So Microsoft created the code, they created the logic, and then the vendors figured out how to actually implement this code directly within their SBC. So it's not a separate server, right? There's nothing outside of a current SBC that they have, but rather the code is integrated into an on-chip solution directly within the SBC so that there's a Windows server running this various client communication. So in the olden days of Skype for Business, we had the same type of concept with an SBA. And there was also what was known as a survivable branch server. The server part is not an option here. It can only be built into the SBAs. The solution is managed and maintained by the vendor. You don't get updates to this directly from Microsoft. So if you have an audio code solution and you've turned this on, you would get all of your updates and configurations directly from audio codes. Or maybe you've decided to do an Oracle or a Ribbon solution, that's your SBCs, great. Then that's going to end, or an AnyNote. It really doesn't matter where these solutions come from. The end point is that it's managed by the vendor and not by Microsoft. So it's an interesting solution that works well. And again, the 4 vendors that are listed have their version 1 from Microsoft. It's going to be progressed on beyond this, but what we get today, that's key, right? What we get today is ability to make an inbound and outbound call. That seems sort of obvious, but that's important. We have the ability to mute and unmute the calls, so basic call controls. Hold and unhold, again, basic call controls. DTMF continues to work, and you don't lose any of the CDR call records or your actual history while there's an outage, because that information is gathered and then uploaded from the SBA to Microsoft when the communication goes back online. Now, today there's a limitation that there is a 24-hour limit. And now the limit's not from the time the outage starts, but the time the client logged in. So the background to this concept is a user logs into Teams, whether it be they are currently logged in or they just logged in. When you do so, every 24 hours, if you're currently logged in, or when you log in, you're requesting a new token. That token is only valid for 24 hours. So let's say it's 8 a.m. at my office. I logged in, it's Tuesday. So I logged in Monday at 8 a.m. the previous day. 8 a.m. Tuesday, I'm still logged in. In the background, just got a new token. So my starting point is at 8 a.m. Conversely, I decide to come into the office and I have not logged in Monday. It's now Tuesday and it's 10 a.m. and I'm just logging in. My 24-hour clock starts at 10 a.m. So it's not going to be the same for every user. It'll differ based off when they last logged in, but that 24-hour window is a current limitation of the solution because within the 24 hours, you expire. So you ask, well, could that mean you only have 5 minutes or less? Well, it sure could. If I had last logged in at 9 a.m. and the previous day, and now it's 8:55 and the internet just goes out, my Teams client would go to get a new token at 9 a.m. because I need my 24-hour token expired and I would not have the option to do so. So there are limitations on how long this will work. The real basic concept of this is it's midday, we're working, things go out, we're not impacted, things come back, and everything continues on, and we're all happy. So Microsoft is working on extending that time and getting it longer in the next iteration. But yeah, it's not a total of 24 hours, it's up to 24 hours. Also not available when you are in this offline mode, voice over IP calls, it's PSTN to PSTN only. The ability to really make changes and do things to the voice infrastructure, the UX, such as add and remove users from your speed dial, modify things, that's all locked out. That's not going to work. Call escalation, adding multiple users, that requires what's known as an MCU or a backend conferencing solution that you can't reach the conferencing solution, so that's not going to work. And then it lists complex features such as call forwarding, call queues, delegation, things of that nature. Some of that may work depending on what the outage actually is. So for example, if the problem is you can't reach user A can reach user B in a different office. User B can still get to the Microsoft solution, but user A cannot for whatever reason. Well, user A will be in the offline mode, and when they make a call to the auto attendant, that'll still be up because Microsoft themselves aren't down. The issue is with user A's office. In that scenario, they would then be able to hit the auto attendant and request user B, and user B would be able to be wrong because they can still talk to Microsoft. So there's some key scenarios where things may still continue to work versus not, but in general, we just say call forwarding, call queues, auto attendants, things of that nature are not going to work. And then as mentioned, the 24 hours. So how does this work? How does this look? So when we're online, which is the concept on the left, when we're online, everything's happy. You have multiple things happening net new. First, you have your SPA configured, and that configuration is dependent on the vendor. So everybody's implementation is different, but the key underlying concepts are all the same. It's using Azure AD, it's using Azure itself, it is using the local bits, and it has this big cached object that exists on the SBA. So the SBA itself is using Graph API to sync user information from your routes to your block rules to any history information, all of that, right? Trunk normalization, whatever it happens to be, all that information is cached down to the SBA. So it's talking directly to the Microsoft Cloud to get that information. It's also talking to the user. So when the user logs into Teams, it gets the configuration setting that says, hey, your administrator set you up to say you're an SBA user. So therefore, you're going to talk to this SBA as your main SBA contact. Okay, great. So now you know that you need to talk to this SBA and you go check in to say, hey, SBA, here I am, you're there, we're there, great. And so there's a local registration that happens with the client to the SBA. The SBA is also talking to the SBC, and that's just your basic communications for any kind of SIP invites that may come from the user when things go down. The client itself talks to the SBC over SRTP and ICE, so that allows the communication to occur from a secure RTP perspective, and then the SBC talks SIP to the cloud. So all of those kind of triangle of loves, two of them going on together, that information is going on all the time in a happy online world. It's not constant communication, but it is constant check-ins to make sure things are going there. There's post keep alives that are happening, validations that are happening. But when you have an SBA in the environment, the SBC is capable of communicating and getting communication directly from the SBA to the SBC. That's what allows us, in the event of a call going, the connection lost, we don't lose a call. If you're in the middle of a call, the client's still talking to the SBC via your media bypass and the SIP communication, so no issues, no worries, right? Everything stays up and everybody's happy. When things go back online, same thing happens. Nothing's really changed from that immediate call flow, but things will get uploaded and changed once that media comes back on and the client's able to log back into the Teams infrastructure. So when it all comes down to it, when the connection's lost and the user is making calls, he'll be in a limited mode. He'll be able to see and hit the SBC. The SBC knows to fork the call, basically saying, hey, call is up. I can't send it outbound. Things are bad. I know they're bad. So therefore, I will just go into media bypass, user bypass SBA mode, and things all go down. And so things go off on their way. When it all comes back online, the reverse happens. It all rebuilds itself from an architecture and gets back to our online mode. And at that point, the CDR information is all uploaded from the local proxy that's on the local proxy database that's on the SBA. That information is then pushed up to the cloud, and then everything's back in sync, and everybody's got all the information. No data is lost, and we're all back up and good to go. So that's the basics of how the SBA works today. Again, there's 4 vendors that are providing the services. There is the AnyNote solution, the Ribbon solution, the AudioCode solution, and the Oracle solution. So T-Systems, AnyNode, AudioCodes, Ribbon, Oracle. If you're interested in the solution, you would reach out to those vendors specifically to get their version of the SBA appliance, ensure that your SBC has the capability to run this. In general, if it's a late version that was recent and newer, then yeah, you can take your old hardware and turn it into a new version of the SBA, but contact those vendors directly to ensure that these solutions are available for you. And with that, I appreciate your time and thanks so much.